Hello there, guys. Fundamental Math here. This is a concept that students have to learn or are tested over pictorially using computation, algorithm, and on the number line. So I am going to do my best to do all three. So here we go. Carlos buys a 5-pound watermelon. He then cuts the watermelon into 1 6-pound portions. How many portions was Carlos able to cut from his watermelon? So what we're first going to do is we're going to circle important numbers. So we have 5, and then we have 1 6-pound, and we're going to box in our key indicating words. So I know right here I'm cutting it, right? And so if I have portions, I know that I need to cut in even portions. And what operation represents evenly distributing anything is division. So right here we have 5 divided by 1/6 portions, okay? And I tell my students, if you start with a whole number right here, that 5 is a whole number, you're going to end with a whole number. Okay, so algorithmically, what you're going to essentially do is, I know that you guys probably learned this, keep, change, flip, or you're taking that whole number, dividing it by a unit fraction, which means you're going to do the opposite, the inverse operation, which is multiplying your whole number times your denominator. And then keeping that as a whole number, because if you start with a whole, you're going to end with a whole. And 5 times 6 is 30. So how many portions was Carlos able to cut from his watermelon? It'll be 30 portions. Okay, so now what I'm going to do is I'm going to represent this pictorially. So that was my algorithm right here. All right, pictorially, my 5 is a whole number. So what that is saying that I need 5 holes, and I'm going to use rectangles right here. Okay, and do my best to draw them neatly. 3, 4, 5. Okay, and then I'm going to take my denominator down here, the 6 right here. All right, and it's telling me that I need 1/6. I need 6 in each of these holes. So what I'm going to do is cut this up to where I have 6 sections, which means I need to draw 5 partitions, 1 less line. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I've partitioned and given myself 6 sections in each of these rectangles. So what I'm going to do is I'm going to count how many one piece out of the 6 I have. So I'm actually going to count these. So I have 1, 2, 3, 4, 5, 6. I'm going to keep counting. Okay, so I continue counting each of those 1 out of the 6 pieces, and I ended up down here with 30. Okay, so I literally just counted them from 1 to 30. So that will answer that question pictorially. Okay, and then what we're going to do is the number line. So this is pictorially how it is represented. And then we're going to do our number line, okay? So what our number line is saying is that, okay, my whole number is 5. So I'm going to number my number line from 0 to 5. So that's going to be 0, 1, 2, 3, 4, and then 5. Now, in between each of the numbers, I'm going to make certain that I can make 6 jumps, because remember, that's what our denominator says. It says 6, which means just like when we're drawing the rectangles, I'm going to draw 1 line less in order to get 6 jumps in between each whole number. So that means 5 lines. 1, 2, 3, 4, 5, which permits 1, 2, 3, 4, 5, 6 jumps in between each whole number. And I'm going to continue doing that all the way down. Okay, so I have made it to where I have 6 jumps in between each of my whole numbers. I'm going to change my color here. And then we're going to count how many jumps it takes to get from 0 all the way to 5. Okay, starting with 0. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, it took 30 jumps. Therefore, my answer is now represented on a number line. Happy fundamental math.